Hello everyone, my name is Andrei Cozma and I'm a systems engineer at Tenlog Devices. During this session, I'll be taking you through the process of implementing a vision-based people detection application using data from a 3D time-of-flight camera and artificial intelligence techniques. Before we dive deeper into the actual implementation, let me give you a quick overview on what the time-of-flight, in short ToF technology is, and what are some of the advantages it brings to a set of applications requiring people and objects detection and classification. Okay, so what exactly is 3D time-of-flight? 3D time-of-flight is an industry term used to describe a type of flash LiDAR used for depth sensing at ranges typically less than 10 meters from the source. The way it works is that it sends out light in the infrared spectrum from one or more laser sources depending on how far it needs to see towards the scene of interest. The light reflects off the objects in the scene at different points and returns onto a sensor, which for this platform is a charge coupled device, or CCD. The time it takes for the light to be sent out and return is measured, and using the known value of the speed of light, which is 300 million meters per second, the distance of each particular point in the scene is determined. But making millimeter accurate distance measurements by measuring the light travel time is not practical, since it requires very fast sampling rates. For this reason, the ADI time-of-flight technology uses a special technique to measure the energy of the light returning to the sensor in two different time windows of known duration, and the distance is computed as being the ratio of the energy in the first time window to the total energy in both time windows, multiplied by the distance the light would travel in the sampling time window. Compared to traditional 2D cameras, which generate a color image of the scene, a 3D camera outputs a depth map where each pixel represents the distance of the corresponding point in the scene to the camera. This picture here shows how a depth map looks like, where the warm colors indicate smaller distances, while the cold colors indicate further distances. A 3D camera also outputs a black and white IR image synchronized with the depth image, which is actually a representation of the total received light energy. It is this combination of the 3D depth map and the 2D IR image that enables enhanced object detection, classification, and tracking in the metric space.